Alright, so I want to show you how to derive the quadratic formula from the polynomial form of a quadratic equation. So ax squared plus bx plus c equals 0. Um, let's turn that into x equals negative b plus or minus square root of b squared minus 4ac over 2a. Right? How do you get from here to here? Well, good question. So the key to this is the idea of completing the square. So let me try to go over that. Um, it's really nice, okay. So when you're solving quadratic um, equations, and you can get it down to something that a factor times a factor equals 0, and then you can set each one of the factors to 0, and then solve for the possibilities of x. Um, so what you'd like to do is to get this polynomial in a form to where it's easy to factor it like that. The easiest thing in the world to factor is x squared, right? Because you can just split it up into x times x, right? So if you think of that as a square, which this is the basis of this stuff, right? If you can visualize a shape that has where you can do its area is length times width, and it's a square, then it's easy to factor because it's just the factors are the side lengths. Okay, so for example, say like instead of the very simple x squared, I've got this binomial x squared plus bx. Okay, so I could visualize what this means in terms of geometry as a square plus a rectangle. So x squared is a square with side lengths x. It's an x by x square. Plus bx. So that's a rectangle like b times x, which is bx, right? So the area of that rectangle is bx. So I can visualize this scenario as a square plus a rectangle. The rectangle having the area b by x. Okay. Now what I would like to do is to turn this situation into a square somehow, so that I could write it as two factors of that common side length. All right, so check this out. So this is very visual. So this b by x rectangle, I'm going to split in two for this reason. Let's see. So let me copy this. So if we take this x by x square, and I take half of this rectangle and put it here, and I take the other half of it and I rotate it. Oops. Sorry. Let me take just this half. And I rotate it and I put it down there. I basically almost have a square, except that there's this little chunk missing. Okay, so let's see what we have so far. So this part is x. Okay, now what's this width? It used to be b, but we cut it in half, right, to chop it into these two thinner rectangles. So this is b over 2. And then this length is still x, right? It's the same. So this is b over 2. That little guy there, that's b over 2. That's b over 2. All right. So what is this square? Well, its length is b over 2, and its height is b over 2. So the area of that square is b over 2 squared. In other words, if I tack on a b over 2 squared to this polynomial, I'll be able to factor it very easily. So in other words, if I add that on, I'll be able to call this side length x plus b over 2, and the total area will be x plus b over 2 squared, right? X plus b over 2 plus times x plus b over 2. Um, so that is the idea. So I could add b over 2 squared to that. Now I can't just add stuff to polynomials, without there being consequences. That changes the value of it, right? So on the other side of the equation, I should have made this equation. I'm going to, do a minus b over 2 squared, so it all balances out. All right, then I can factor this side as x plus b over 2 times x plus b over 2. Okay, so that's the key to this. Now this is going to be just slightly more involved, but not really. All right, first thing we want to do is we want to move this c over to the other side so that we've just got ax squared plus bx, so that we can do this sort of thing to it. So we've got let's change colors here, ax squared plus bx equals negative c. Because we're going to complete the square over here on this part, right? And then when we add that thing to it, we'll you add to the other side too. Sorry, I said subtract, but you add to both sides. If you add something to both sides of the equation stays true. Okay, sorry. So I'm going to add something to this side, and I'll add something to this side, and then we'll be fine. Okay, so what we have here so far. See, let me just grab. Actually, let me back up. What we really want to get is just x squared plus bx. So we can do this exact thing. So let's divide both sides of the equation by a. Divide by a. So this is gone. So we've got x squared plus b over a x. We're dividing both sides by a equals negative c over a. Okay, now we can complete the square, which will allow us to solve. And I'm kind of just telling you that the method here is we want to complete the square so that we can get into this form. Okay, so what we did over here is we added b over 2 because we cut this in half squared because we're adding this little square. Right. So here we don't have just b, we have b over a. So what we'll really do is b over 2 in this case will be b over 2a. So we're going to add that to both sides of the equation. X squared plus ba x plus b over 2a. So we've got a down there squared equals, now I've got to add that b over 2a squared to this side too, so the equation stays balanced. So c over a plus b over 2a squared. Okay, now let us go ahead and simplify this stuff. Yeah, let's do that. B over 2a squared. So you got minus c over a plus, so that'd be b squared over 2a squared, which would be 4a squared. Yeah. So 2 squared is 4, a squared is a squared. Alright, and then we can actually get common denominators here. We want to add these fractions. So if I want to so the common denominator here would be 4a squared, so I can just multiply this guy by 4a to make it into 4a squared, because 4a times a would be 4a squared. Um, so, uh, so this will be, so we're going to multiply the top and the bottom by 4a, so this will be 4ac, negative 4ac over 4a squared plus b squared over 4a squared. Alright, starting to look vaguely familiar. So we've got common denominators here, so this would be minus 4ac plus b squared over 4a squared, and I'm just going to flip the order around, because minus 4ac plus b squared is equivalent to b squared minus 4ac, right? Alright, this is looking good, right? Over 4a squared. Okay, now let's go back to dealing with this side. Now that we've completed the square, we can factor this, and the factors would be what? Would be x plus ba times x plus ba, which we could rewrite as b over 2a would be its factored form. In other words, our side lengths of the square would be x, and then we had b over a, but we cut it in two, so it's b over 2a. So we could rewrite that as x plus b over, back up, just b. I was thinking 2a squared equals b squared minus 4ac over 4a squared. Getting close. So we want to solve for x. So square root both sides. So we've got, let's start writing x. So we square root of this. So x plus b over 2a is equal to plus or minus the square root of minus 4ac over 4a squared. And then we can actually simplify a little bit here. So plus or minus square root of b squared minus 4ac over 4a squared is equivalent to plus or minus square root of b squared minus 4ac over the square root of 4a squared. And then the square root of 4a squared is just 2a. The square root of 4 is 2, square root of a squared is a. So this would just be 2a. And then, so we could subtract b over 2a to solve for x. So x equals, and then we could just put the instead of all this stuff minus b over 2a, we could put negative b over 2a and plus or minus the square root of b squared minus 4ac over 2a, and then this is equivalent to, these are two fractions with the same denominator, so this, let's write it up here, is equivalent to, and I'll put this in a different color so we can see, x equals negative b, and then all this is going to go over the same denominator, 2a plus or minus the square root of b squared minus 4ac, boom, in the bag. Alright, so that's what we wanted. So completing the square, yeah, that's the key to it. So hopefully that gives you a better understanding of the quadratic formula and where it came from. And yeah, good luck deriving your own formulas. It's kind of fun. It's kind of intense too. All right, see you later.